Question number 1. Due to illumination by light, the electron and hole concentration in a heavily doped n-type semiconductor increases by delta N and delta P respectively. If Ni is the intrinsic concentration, then which of the following is correct? Whether delta N is greater than delta P, or less than or equal, or multiplication is equal to Ni square. In question he is saying that there is a semiconductor with n-type. He is giving the heavily doped. This is the confusion part. Heavily doped n-type. Generally, by saying this heavily doped n-type, we will come to the conclusion that heavily doped n-type means electrons will be more than delta N. Delta N is the number of excess electrons. Number of excess electrons. Delta P is equal to number of generated excess holes. By seeing this heavily doped, we will come to the conclusion that delta N is very high than the delta P. So definitely we will choose the option A as correct. But this is wrong. So we will see the concept. Given that there is a semiconductor with n-type, means there are a covalent bonds. By falling the light, illumination means falling the light, then the covalent bond will be break. Then for every covalent bond will break, delta N will be generated, as well as in the absence of the electron, delta P will be generated. Means how many electrons will be generated, that much of holes will be generated. But if we consider as delta N covalent bonds or delta covalent bonds are breaked for light falling, delta N electrons will be generated. Similarly, delta P holes will be generated. So this is equal in all cases. This is equal at every time of the instance by falling the light. See this, in covalent bond, if it is break, delta N electrons will be generated, delta P holes will be generated. These are equal. How many covalent bonds will be generated, that much of electrons will be generated, that much of holes will be generated. So our option answer is always delta N is equal to delta P. Option C is correct. A is wrong, B is wrong, D also wrong. Option C is correct. If we can also see the number of electrons and the number of holes in this semiconductor before the illumination of the light and after the illumination of light. First we will see the before the illumination of light. Given that it is a n-type semiconductor. So the n-type semiconductor, number of electrons in n-type semiconductor is equal to Nd, number of doped atoms. Number of holes in n-type semiconductor is equal to Ni square by Nd. This is the before the illumination of the light. After the light, delta N electrons will be generated, delta P holes will be generated. Therefore, Nn, number of electrons, is equal to Nd plus delta N. Number of holes is equal to Ni square by Nd plus delta P. This is the after the light. After light. This is no need, but we can also, it may be asked in future also. But our actual answer is delta N is equal to delta P.